Good morning, everybody. Thank you very much for Linda for a very kind introduction. And it's my pleasure to be here with this opening speech. I would very much rather be with you all, though, and I send my best wishes to everyone at Stellenbosch in particular, as well as Lucia and Linda. So my talk today is going to be about food safety in the future. And I divided my talk into 4 sections. We're going to look at food security, foodborne pathogens, food safety, food sources. I am not covering allergens. That's being covered by Dr. Crivell at 10 o'clock, and food fraud at 12:15 tomorrow. And also not covering emerging technologies, which is more involved with a roundtable today. So I'm going to focus initially on food security, and some of my information came from recent WHO documents. This one's out for public consultation at the moment. OECD, a local one for Europe from WHO, but there's also a food safety virtual forum last month by IFC. So let's look at food security to start with. We need a food system that is secure from farm to fork. And it's not just safety. We need a food system which gives us a healthy food as well as a safe food, and really we need food that's sustainable. We think of our food systems today as not just purely from the human perspective. We think of the One Health approach, where we need healthy human beings, but in turn we need a healthy environment, and we need our animals, our livestock, and aquaculture as well should be in there to be healthy. And this interaction is very much brought out when we consider the issues of trying to control antimicrobial resistance, because genes, bacterial genes, they don't know about boundaries. They'll jump from fish to animals to humans to soil to water, and so we need to think of the interaction and not have this compartmentalism that has been the issue in the past. So, according to OECD, the world population has 3 challenges. The one that is often cited is that we expect the world population to be in the order of 10 billion people by 2050. Currently, however, 2 billion people do not have regular access to sufficient, safe and nutritious food, and an even greater number are overweight or obese. So we have this imbalance. When we look at like low-income economies, we can see that the trend has improved, that from 2000 to 2016, the proportion that were undernourished has gone from 35% to about 27%. It's not huge, but it's an improvement. Middle income has gone from about 20 to 15. Upper middle income, we're then in like the 12 down to 8. And then the higher income, the undernourishment is very small, around about 3%. However, we look at this overweight and obesity, the overweight being green and the obesity in red, and we can see that the trend from 2000 to 2016, there has been a considerable increase in the obesity in especially the higher income economies. But we also have increase in overweight occurring in the lower income economies as well. The second challenge that needs to be recognised is that food systems are central to the livelihoods of hundreds of millions of households around the world. And that's where, when we get a stress like COVID-19, it puts a huge pressure on the livelihoods of at least 570 million farms worldwide, and as well as pressure and problems on the various stages of the food supply chain. And when we look at what people are doing, then we can see for farming, we have that in green, that when we have our Eastern Southern Africa countries, then about 91% of the employment is in the farming region. When we go to middle income, such as Brazil, it's decreased to about 50%, and we have a greater increase in manufacturing and in food services. And then when we come to the higher income, for example, United States, we had food services at 65%, and of course that will probably affect the salary that people are obtaining as well. We have changes that we can see are going to be, we expect to be happening with regard to trade balances. We have a continuing increase in positive trade balance of North America and Latin America. We have Europe and Central Asia going up. However, we appear to have a gradual decrease expected for sub-Saharan Africa, as well as the Near East and North Africa as well. So these are considerations with regard to our food. And then finally, the third challenge is that food systems is highly dependent on the environment and exerts a considerable pressure on the environment. And we have environmental damage due to food production. 80% of all threatened terrestrial birds, mammal species are in danger because of habitat loss due to agriculture expansion. And food production accounts for a very large proportion of human-generated greenhouse gases. So let's move on to our second topic of foodborne pathogens. Taking the data from WHO. And when we look at the global burden of foodborne diseases, as expressed in disability-adjusted life years, so it's the reduction of productivity of people in their lives. We have in Africa, this column here is South and Eastern Africa. We can see that major loss is due to diarrheal diseases, whereas this proportion is much lower in North America, in Europe, and here's UK is covered here. Increases again in countries such as India. Here's China, where we have a high proportion with hemolynths, which is the red colour, and we can see very low again, Australia, very similar to the UK. Green being invasive infectious diseases. And that can be drilled down, and the details probably lost on our computer screens, as opposed to being in a conference hall. And that actually tells, we can have an idea of which organisms are causing the problems here. We can see our common organisms of our pathogenic E. coli, our campes, etc. Now that cost, if you put in economic terms, here's the latest data from the UK, and this came out earlier this year, and it's for UK in 2018, and it's estimated when we add up the cost due to illness, lost earnings, death, disturbance, medical costs, school absence, individual expenses, that the UK foodborne diseases cost the UK £9 billion. Apply that roughly by 20 for South African currency, or about 1.5 with regard to US dollars. So it's a considerable cost to the UK society. When we look at the cost of unsafe food in low and middle income economies, you can see in Asia a very high proportion, number of incidences, around about 17 million in Asia, Africa around about 10 million, and developed countries, you can see it's much lower. Of course, that's what drives the loss in income. So we have hemolynths again. We have the alpha toxins coming in as well. Productivity loss, we look at it by country. Here we can see for China, around about $30 billion US estimated to be lost due to foodborne diseases in China. Here we got Brazil, and here we got South Africa, around about the $2.5 billion US. Now, as well as agricultural changes, we expect to have a climate change which will affect foodborne diseases. Here's a newspaper page that's from South Africa from January last year. Africa will be hardest hit by climate change, global experts raise concern. And when we look at the WHO document on food safety and climate change, we can see that there are predictions with regard to changes in where the crops will be grown, and how we'll therefore get changes in severity of the pests and diseases, and we'll therefore have changes in food production, animal welfare, and increase in flooding could increase microbial contamination. Mycotoxins is a topic which Prof. Miller is covering at later on this afternoon, so I'm not dealing with in any detail, but it is a major issue with regard to climate change, especially with fusarium and fumosins, and particularly with Aspergillus flavus as well, which affects maize, and of course the aflatoxins, which are potent carcinogens. With regard to water, we've got algal blooms, which will probably increase, or could increase, the contamination of our shellfish, which can carry various toxins. And then our waterborne bacterial pathogens, especially our Vibrio cholera, again associated with consumption of contaminated water filtering organisms such as clams and mussels, and change in water temperature and salinity may well change the prevalence of the Vibrio in water. So when we look at our recognised foodborne pathogens, we look at the current group, and of course this is historically based because of the reliance on agar plates, detection using phenotypic biochemical tests and PCR probes, and we have our Salmonella campi being a special topic. Tomorrow, pathogenic E. coli 157, Clostridia listeria cytogenes, Jeff Farber is covering later today, as well as the toxins, both bacterial and fungal. In the future, we think it's going to move away from this current. There's going to be more emphasis and utilization on DNA sequence-based methods. That should will broaden the range of organisms of concern, including the viruses, because of course they don't grow on agar plates. And let's not be too surprised if we find some unexpected organism, because at the moment we often look for what we expect to find. We don't use every agar plate formulation in the cupboard. We look for what we anticipate could be there. In between, we have our emergent organisms, the Chronobacter associated with infant formula and the infection of neonates. Something which I've worked on more, Archobacter, which is a Campylobacter-like organism. But then we have our variations, recognizing that Salmonella is highly diverse, but it's also, we have our Salmonella gona in particular, which does not produce hydrogen sulfide, monophasic. Then we have a wider range of pathogenic E. coli, various serotypes, but we also have a cousin, Escherichia bureti, which can include Shiga toxin. And our ability to characterize, differentiate genotype can be based now on multilevel sequence typing. So we're able to differentiate strains that we couldn't differentiate before. Sometimes that's not adequate, and CRISPR-Cas arrays are very useful. And of course, we're broadening out as more and more sequence-based approaches are used with microbiomes and metagenomics. And of course, we have viruses. And we have SARS, the issue over whether SARS causes COVID-19 infection through food packaging and foods. I run a blog on that. You can click here. So the question has been, okay, viruses causing foodborne infection? Well, yes, noroviruses do, hepatitis do. They're more the lower intestinal tract. Flu, COVID-19, not such a major cause of concern. And the opinion, WHO and ICMSF, is very much, it's very unlikely that ingestion will cause illness. And one needs to recognize that it could be present, it could be foodborne, does not necessarily mean it causes an infection. And many of the incidences where the virus has been found on packaging and on food, it's been finding genetic material, not necessarily a live virus. But that nicely brings us on to the topic of real-time genomic epidemiology, a topic that I've lectured on and taught workshops, etc., for many years to students, and I felt there's a bit of an academic topic, and now it's something which is just everybody on the high street knows what real-time genomic epidemiology is, even if they don't know what the term, because we have the tracking of the COVID-19, the SARS virus. NextGen being a very useful site for doing this, and for foodborne pathogens, we have a number of networks. Been out there for a few years, but now the awareness is greater. Genome Tracker and the NIH. We'll just go to that one. And NIH, I mean, you can click on how many new isolates today? Well, okay, 29 new isolates. We can click on that, and they're already by SNP analysis, they're already being clustered in real time. So this therefore gives us the potential of having like a smart algorithm or spotting an isolate from food, an isolate from clinical sample, an isolate from a factory swab, an isolate from a cow, matching it up. And isolates from different states, different countries, they could be matched up. And so in the future, this gives us like a real-time early detection of outbreaks and their sources, and we're on the cusp of that. But there's something which does aggravate me on this area. This is a diagram from the outbreak of Salmonella associated with France a couple of years ago, caused infections in infant formula. Here's a cluster of strains, 37 strains, 26 SNP differences. But that was retrospective. When you have that genome, it's not being used to predict the colony appearance, because by looking at that genome, you would know that the PHS-A gene has been mutated, therefore it will not produce hydrogen sulfide, and therefore it will not give typical Salmonella colony appearance on XLD, which is the major agar which is used for Salmonella. So really in the future what we need a more informed, yeah, great to do the genomics, great to do the SNP typing, but you could predict when there's a unique colony appearance or whether it will give an atypical test result. And that would be very useful for food laboratories, clinical laboratories, to know, oh, this variant, this organism of concern could be pulled out more because it has this particular trait associated with it. And, with regard to genomic epidemiology, the emphasis on whole genome sequencing, we can see this with regard to PulseNet for its surveillance. It's named PulseNet because of pulse field gel electrophoresis, but they've moved away from pulse field gel electrophoresis to whole genome sequencing, in particular for genome MLST. And that's covering a large part of the world, and we have PulseNet Africa in green here. So let's move on with topic. Let's look at food safety. And food safety, where have we been going? Well, we've had this control, we've had the old-time control of end product testing. Limited sampling volume, absolutely small percentage has been sampled. The detection limit is inadequate. Detection limit of 10 CFUs per gram or 100 CFUs per gram isn't useful when it comes to eating 100 grams, 200 grams of food. The organism could be below the detection limit but still cause infection. And you only have time and resources to look for a limited range of organisms. So then we have the question, that's risk analysis, we have HACCP, is it safe? And we can now bring together like this for risk communication. We have a scientific committee or look for hazard identification, we look at population probability of infection. We can bring in genomic, metagenomic, epidemiological data. Great. But there's another side to this. The risk communication, we've got to communicate that to the general public. And we've seen in the past year how untrusting the general public can be. And yeah, it's fine to estimate this for a population, but there's a personal fear as well. And then we have the issue of social media. We have all this data coming in from genomic studies, laboratory studies, but the general public will have information from social media. And we have an infodemic. Because everyone's got a phone. We've evolved wondrously that we can now have opposing thumbs, and these are magic with regard to operating a telephone. So we've evolved, we've gone to upright, and now we've gone back to a stooping posture, clicking away. However, we still need to learn to wash our hands. And where's that gone? Well, now you can go onto iwaspoisoned.com. You can download the app. Here we have a map of US, and you see the number of alerts in the different cities and different areas. You could walk towards a restaurant and just check the app, say, ooh, somebody wasn't too happy here last week. But let's not look at America, let's look at South Africa. So this is from January. And we had a couple complaints in Cape Town. We can zoom in and we can see on the map where those complaints were. You can look up what people were complaining about. So let's look at food sources, and really I'm going back to food security as well. So world demographics, 1960, we had this pyramid of age and population size. By 2020, we have this bulging of the more middle age groups, the 40s, the 50s, going up to the 60s. By 2050, not only do we have an increase in the total population size, but we have a considerable increase in the age profile and therefore susceptibility to infection. Where is this going to occur? Well, it's going to be in Africa. A large proportion of that change is estimated to be in Africa. Now, if we're going to go up from increase of 35% by 2050, that's 35%. However, to feed this population, we estimated that crop production needs to double. 35% needs 100%. Why this difference? Well, it's because as economies grow, people want to eat more meat. And in order to sustain that increase in meat demand, you need to increase your crop production. If meat is your crop and meat is your source. So let's look at protein sources. 4 protein sources. Conventional meat, familiar with. Meat analogues, such as from insect protein. Cell-based meat or cultured meat. And then we have our plant-based meat as well. So the plant proteins are a major industry, expected to rise to about 9 billion by 2006, and various proteins are being pulled out, used there, and our filamentous fungi are just for convenience, are included in this group. But it's not totally safe. We have increased exposure potentially to mycotoxins. We have new food allergies. We have issues over nickel and toxic phytochemicals, and free asparagine as well with regard to acrylamide production. So these are issues that need to be addressed with regard to increases in plant production. Edible insects is an excellent article by WHO on looking at edible insects from a food safety perspective. And we can see the interest in insects because of the conversion ratio, the decrease in water, the smaller footprint, environmental footprint that's required. And we can see the predicted increase in insect protein market. Cultured meat or cell-based meat, you can go a cell bank, take a stem cell line, develop it in a bioreactor, and here this was no-kill lab-grown meat goes on sale for the first time, and this was a restaurant in Singapore. Eat just chicken bites, so Singapore reference, and the meat uses that word, grown bioreactor, 1,200 litres. The growth medium does include fetal bovine serum, which is a blood extract. The producers say that this is largely removed before consumption, but the aim will be to have a plant-based growth medium in the future. And that's because with cultured meat, there are issues over nomenclature, decisions over which stem cell lines may be used and whether they're commercially shared or in private banks, definitions, safety regulations, but especially social acceptance. Do we label it as lab-grown meat? How well do we know the origin of the cell cultures which were used? And of course, our safety regulations are very much based upon conventional meat, the abattoir and aquaculture. So what is safe food? That's what the whole summit is about. So definition, WHO, is used from Coda Samantarius, assurance that food will not cause adverse health effects to the consumer when it's prepared and or eaten according to its intended use. How will we know it's not going to cause adverse health? Because these days, we know a little bit more. If we don't look, we don't find, but if we look, we may find. And we have not only microbiome, but metabolomics. We can see how the metabolism of the gut flora changes. And it's not just the gut flora, it's those metabolites from the gut affect the brain activity and it affects the immune system. So we have this axis. So if our food alters our microbiome, it can affect our brain activity and our immune system, and therefore and our growth, our bone as well. So these are things which in the future we're going to hopefully understand more, and we have questions about functional foods and how much pre and probiotics may be used to alter when it comes to the brain and immune system axes as well. So to bring us together, where are we going? Well, we have so much data. And so people are talking about data science and big data, and we need to use that information that's out there with regard to food safety, risk assessments. And here's a diagram from Marv in 2017. The range of databases is huge. Maximum limits, food safety alerts. These could potentially all be pulled together to help make informed decisions. But what we do need to ensure is that this data is accurately curated, verified, and interpreted. So, to summarize, foodborne trends, foodborne pathogens, they're going to continue to evolve. So therefore we need to keep improving our detection and ability to predict. Control of these foodborne pathogens will be more risk-based using genomic data, but we need to inform the consumer of the relevance of an organism. The population size is going to increase. There's going to be a proportionately increase in aged and susceptible individuals, and therefore we have to look at a wider range of protein sources, plant, insect, cultured meat, and our safety regulations will need to keep up with these novel developments. So thank you very much for your attendance. These are the links for the various websites that I've used, and I hope you enjoy the rest of the conference. Thank you very much.